Distributed text messaging. Mobile telephony gave us a new text message system, SMS short message service. An SMS sender, SMSC, is responsible for handling the SMS operations of a wireless network. When an SMS message is sent from a mobile phone, it will reach an SMS sender first. The SMSC stores the messages, extracts the destination from it, and then forwards the SMS message towards the destination. An SMS message may need to pass through more than one network entity, SMSC and SMS gateway, before reaching the destination. The main duty of an SMSC is to route SMS messages and regulate the process. If the recipient is unavailable, for example, when the mobile phone is switched off, the SMSC will store the SMS message. It will forward the SMS message when the recipient is available. If a mobile telephone received the message, it will send an acknowledgement back. Usually the message will be discarded after 2 days if the destination cannot be reached. Very often an SMSC is dedicated to handle the SMS traffic of one wireless network. A network operator usually manages its own SMSC and locates them inside its wireless network system. However, it is possible for a network operator to use a third-party SMSC that is located outside the wireless network system. You must know the address of the wireless network operator's SMSC in order to use SMS messaging with your mobile phone. Typically, an SMSC addresses an ordinary phone number in the international format. A mobile phone should have a menu option that can be used to configure the SMSC address. Normally, the SMSC address is preset in the SIM card by the wireless network operator, which means you do not need to make any changes to it. Now check following words and sentences. SMS gateway www.developershome.com/SMS/SMS_tutorial page equals gateway next generation IP SMSC EMS communication with the SMSC through TCP IP SMS connection. Use the internet to send large volume of messages directly to the SMSC IP SMSC the PC Enterprise SMS server to send received SMS messages to mobile devices with your computer. Development up to this point has given us a centralized system where SMSC, SMS gateways become bigger and bigger and you have top-to-down system. This system is tried in few financial transactions but all are bank-centric. To use text messaging in financial transaction on mobiles, we suggest using bottom-to-up approach. In mobile network follows this cell. Let us check an example. BTS, base transceiver station, BTS X1, BTS Y1, BTS G11, BTS Z12 BSC, base station controller, BSC X1, BSC Y1, BSC Z1. MTSO mobile telephone switching office, MTSO1. In the following example we will add 3 paying mobiles XP1, YP1 and ZP1 in respective cells. We also add 4 receiving mobiles XR1, YR1, ZR1 and RR1. Please also observe we have serve X1 connected to the SCX1, serve Y1 connected to the SCY1, serve Z1 connected to the SCZ1 and serve M1 connected to MTSO1. Logically one can classify mobile phones as follows. Class BP, mobile phone used to make payments for services and purchase of goods. Owned by individuals only. Carry balance and mobile in area where service is provided. Presently mobile XP1, YP1 and ZP1. Class RA, mobile phone used to receive payment only. Owned by utility companies like Reliance Energy. Once registered, stays at a fixed location. Can receive payments from any mobile of the system, from any location in the area where service is provided. Presently mobile XR1. Class RB, mobile phone used to receive payment only. Owned by shops and establishment, where people go to buy goods and services and make payment for the same across the counter or in person, say like Shoppers Stop or a small shop in a vegetable market. Once registered, stays at a fixed location. By logic it can receive payments from a mobile which has to be in same cell only. Presently mobile YR1 and ZR1. Class RC, mobile phone used to receive payment only. Owned by a person or establishment like delivery boy of pizza parcel service, your taxiwala etc., who are mobile in area where service is provided. can receive payments from any mobile only when they are in same cell that of paying mobile. Presently mobile are R1. As per mobile technology, the SC controls numbers of cells known as location area. Each VTS of cell is connected to the SC of location area, and in turn all the SC of MTSO is connected to MSC, which is connected to the LR and HLR database. And all MSC are connected to centralized SNSC, thus a SNS send by any mobile will reach through this network to SNSC and store it there. Through this network any mobile which enter a cell will get itself registered in the LR, and all active mobile in MSC will have location registry in the LR. A visitor location register, VLR, is a database which contains temporary information concerning the mobile subscribers that are currently located in a given MSC serving area. A home location register, HLR, is a database that contains semi-permanent mobile subscriber information for a wireless carrier's entire subscriber base. HLR is location registry of all mobiles of the service provider. Before going into layout details and functions of each components of distributed text messaging for financial transactions on mobile phone, let's check out components of text message and each one's role of making the transaction safe by mobile phone. Text message should help us to validation and authentication the transaction. Unlock the locks, checking out logical locks. Check out balance and process the payment transaction. On and above sender's mobile number and recipient mobile number. As entire subscriber base may not opt for this service, a separate database, the FHLR, is created where all the mobile numbers are listed as per class BP, RA, RV, and RC. In the following diagram, we have added two databases, the FHLR and the FVLR1. In conjecture with carriers HLR and the FHLR, Serve M1 will tabulate in the FVLR1 all mobiles present in MSC1, MTSO1. Also will list in a table all from all mobile of class BP and in a table to all mobile of class RA, RV, and RC in Serve M1 under MTSO1. The FVLR1 table of all mobile present will look like this. And all from and to all tables in Serve M1 will look like this, all from to all, and it will distribute tables from numbers and to numbers in Serve X1 as follows from numbers to numbers, tables from numbers and to numbers in Serve Y1 as follows from numbers to numbers, tables from numbers and to numbers in Serve Z1 as follows from numbers to numbers. Now if mobile XP1 moves from cell X1 to cell Y1, then from numbers in Serve X1 and Serve Y1 will change to from numbers in Serve X1, from numbers in Serve Y1, and similarly distributed check first tables in Serve X1, Serve Y1, and Serve Z1 will look like following: check first Serve X1, check first Serve Y1, check first Serve Z1. Logically, mobile phones are classified as above, and receiving mobiles class RA, RV, and RC are not provided with payment function on handset, and also servers will not allow the payment from them as they are only listed into numbers, and payment will be allowed only from numbers list. This is to safeguard the accumulated balance of payment they receive over a time period. Thus the function of the system is to provide maximum possible safeguard to paying mobiles listed in from numbers list. Now text message generated from mobile handset will first reach to relevant VSC in which the mobile is at present in. From there it will reach the relevant server, like Serve X1, in case of mobile is in cell X1. Here the first check is, if mobile is not listed in from numbers list of the server, will generate a response unauthorized approach, or still better, no response will be given. Secondly, at Serve X1 level, check first process is initiated. If found OK, text message will be pushed to Serve M1. If found not OK, a text message is sent to mobile failed first. At Serve M1 level, receiving mobile number status with respect to in same cell is checked. If not OK, sent message not valid, otherwise received to check second. If failed in check second, sent message failed second. Otherwise proceed to check balance, and if payment is less than balance, process payment, wait for acceptance from receiving server and issue acceptance message to sender's mobile. Referring to a figure, let us create an example and give you a live demo. Assign paying mobile and receiving mobiles as follows. Paying mobiles are XQ1, YQ1 and ZQ1 belongs to respective mobile and from numbers and respective persons as shown. Receiving mobiles are R1 belongs to taxi, location is movable and status, it should be in same cell as paying mobile. XR1 belongs to Reliance Energy, location is fixed and status is paying mobile, can be from any cell. Similarly, YR1 and ZR1 belong to Shoppers Stop and a vegetable vendor as stated. Their location are fixed and status is paying mobile, has to be in same cell. Now Mr. Patel, Mrs. Shah and Ms. Mehta has to pay their electric bill to Reliance Energy. It is simple, XQ1, YQ1 and ZQ1 pays to XR1. XQ1 and XR1 are in cell X1 and underserved X1, while YQ1 is in cell Y1 and underserved Y1 and ZQ1 is in cell G11 and underserved Z1. Looking at status of mobile XR1 all can pay from their present position. Similarly, YQ1 can make payment to YR1 and ZQ1 to ZR1 as status conditionality allows these. Now Mr. Patel wants to make payment to Shoppers Stop. It is logical that he will visit the place, make his selection, make purchase and pay at its counter. Before you move mobile XQ1 to cell Y1, where YR1 is, you can try to make payment from present position of XQ1 and you should receive message not valid. Now you assume that Mr. Patel has taken taxi R1 to Shoppers Stop. Hence you move both XQ1 and R1 to cell Y1. And with this you can make payment from XQ1 to R1 and employer 1. Similarly, you can move XQ1 to cell G11 to make payment to ZR1. Move YQ1 to cell G11 to make payment to ZR1 and ZQ1 to cell Y1 to make payment to YR1. Regarding check first and check second, without going into complicated details, we give you two simple options, incorrect and correct at both the points. Check first at the SC and serve X1 etc. and check second at MSC1 and serve M1. If conditions are not fulfilled at the SC level, failed first message will be given, and if conditions are not fulfilled at MSC1, MTSO1 level, failed second message will be given even before checking balance at MSC1 level. As paying mobile and receiving mobile can be with different wireless operators, above figure shows a probable layout. When message reaches at serve M level and after verifying check second and before checking the balance, serve M will check out with the F main server for vicinity of receiving mobile, not exact location with reference to status, and if OK, process the payment and message will pass through the F main server to receiving operator system to the relevant mobile. Next, refer to Payment Front Concept Demo Process.
We have shown you a technique in distributed text messaging which can be used in our payment front concept. Next, we are to show you how an interactive model of the same in Microsoft Access database will perform step by step and will give you end result. Payment checks at the server and in payment front concept process.
In this layout, a note is attached to give you a quick reference to various titles and to the mobile numbers, their locations and the status. In reality, mobile XQ1, when moved from cell X1 to say cell Y1, then data is automatically changed in HLR database register. But in this demo you have to move XQ1 from cell X1 to cell Y1 by clicking XQ1 in cell Y1. Before doing that, you should know the present location of mobiles by clicking Present Location button. Present Location form shows you all X are in cell X1, all Y are in cell Y1 and all Z are in cell G11. Visiting R1 is in cell Z12. Now Mr. Patel, Mrs. Shah and Ms. Mehta has to pay their electric bill to Reliance Energy. Looking at status of mobile XR1, all can pay from their present position. It is simple. Assume that XQ1, Mr. Patel mobile number 9323952409 has to pay rupees 3,000. For making payment, click XQ1. In message form, enter XR1 as the number. In check first, enter correct. In check second, also enter correct. In pay, enter 3,000. Now you will see form alert payment showing payment at Reliance Energy. Again assume that YP1 Mrs. Shah mobile number 9324884040 has to pay rupees 2,000. For making payment, click YP1. In message form, enter XR1 as the number. In check first now, enter incorrect, instead of correct. In check second now enter correct. In pay, enter 2,000. Now you will see form first message, with remark failed first. Now correct yourself and, for making payment, click YP1. In message form, enter XR1 as the number. In check first now enter correct. In check second now enter correct, and in pay, enter 2,000. Now you will see form alert payment showing payment at Reliance Energy. Again assume that ZP1 Ms. Meta mobile number 9322712652 has to pay rupees 1,500. For making payment, click ZP1. In message form, enter XR1 as the number. In check first enter correct. But now, in check second enter incorrect. In pay, enter 1,500. Now you will see form second message, with remark failed second. Now correct yourself and for making payment, click ZP1. In message form, enter XR1 as the number. In check first now enter correct. In check second now enter correct, and in pay, enter 1,500. Now you will see form alert payment showing payment at Reliance Energy. Again assume that YP1, Mrs. Shah mobile number 9324884040 has visited Shoppers Stop and has to pay 2,100 towards purchase bill. Without changing present location, YP1 can make payment to YR1 as status conditionality allows these. For making payment, click YP1. In message form, enter YR1 as the number. In check first, enter correct. In check second, enter correct. And in pay, enter 2,100. Now you will see form alert payment showing payment at Shoppers Stop. Assume ZP1 Ms. Meta mobile number 9322712652 has visited vegetable vendor and pay 451 for the purchases. Without changing present location, ZP1 can make payment to ZR1 as status conditionality allows these. For making payment, click ZP1. In message form, enter ZR1 as the number. In check first now enter correct. In check second now enter correct, and in pay, enter 451. Now you will see form alert payment showing payment at vegetable vendor. Now Mr. Patel wants to make payment to Shoppers Stop. It is logical that he will visit the place, make his selection, make purchase and pay at its counter. Before you move mobile XP1 to cell Y1, where YR1 is, you can try to make payment from present position of XP1 to YR1 in cell Y1. And you should receive message not valid. So try to pay rupees 1,698 to YR1 from present location. For making payment, click XP1. In message form, enter YR1 as the number. In check first, enter correct. In check second also enter correct. And in pay, enter 1698. Now you will see form second message, with remark not valid. Now you assume that Mr. Patel has taken taxi RR1 to Shoppers Stop. Hence you move both XP1 and RR1 to cell Y1. And with this you can make payment from XP1 to RR1 and then to YR1. Now, first take XP1 to cell Y1 by clicking XP1 in cell Y1. A form will explain that present mobile XP1 is in some other cell, and by clicking in XP1 in cell Y1, you will trigger its registration in cell Y1, and the same will be registered in database, and subsequently system will update path in mobile XP1 to serve Y1. Henceforward mobile XP1 will communicate with serve Y1 till it moves out of cell Y1 to other cell, where the same procedure is repeated for new location registration and update of new path for communication. Previous position of XP1 is shown. Then, present position of XP1 is shown. Next, take RR1 to cell Y1 by clicking RR1 in cell Y1. A form will explain mobile RR1 is receiving mobile. It represents service like auto rickshaw, taxi or parcel delivery boy. By nature it is mobile and can be in any cell of the system. For communication, one has to be in same cell as you can communicate to them in person only. At present, mobile R1 is in some other cell, and by clicking in R1 in cell Y1, you will trigger its registration in cell Y1, and the same will be registered in database, and subsequently system will update path in mobile R1 to serve Y1. Henceforward, mobile R1 will communicate with serve Y1 till it moves out of cell Y1 to other cell, where the same procedure is repeated for new location registration and update of new path for communication. Previous position of R1 is shown. Then, present position of R1 is shown. Now for making payment, click XP1. In message form, enter R1 as the number. In check first, enter correct. In check second, also enter correct. And in pay, enter 150. Now you will see form alert payment showing payment to taxi. Now for making payment of rupees 1,698 at shopper's stop, click XP1. In message form, enter YR1 as the number. In check first, enter correct. In check second, also enter correct. And in pay, enter 1698. Now you will see form alert payment showing payment at shopper's stop. Last button, in click here to making payment head, is XP 93 29 95 2408. Click it. A form will explain. Here XP1 underline Mr. Patel's son has somehow transferred application from mobile phone XP1 to his mobile phone number 93 23 95 2408. He will become unregistered user to server on his number 93 23 95 2408 when approach the system. Then that approach will be unauthorized approach. In this example you will receive that message, but in actual system no response will be given, and only it will be registered in database as such. See the result of message forms. In this demo, under Service 1, 3 transactions are registered as shown. XP1 has moved to serve Y1 to register 2, hence 5 transactions are registered in serve Y1 as shown. Under serve Z1, 3 transactions are registered as shown. Serve M1 also have recorded all failed transactions of serve X1, serve Y1 and serve Z1. Also all payments are registered in serve M1 of all 3 serves, X1, Y1 and Z1. For simplicity we have only one MTSO of reliance, and all mobiles are of reliance only. Hence only one statement of account is made at serve M1 as shown. This statement will result into checks as shown.